in here, but there's going to be some problems you're going to definitely have to do this off to the side. You'll be in Calculus 3, you'll find yourself still doing this at times. Eventually, some of you will get so good at these, you'll do a lot of these in your head. You'll do this mentally. There's some calc instructors out there, teach Calc 2, and they kind of get upset when they have to show this. They expect you to do it mentally. You know, don't worry if you have to write this stuff all the time. I think it's good to do that. Cool?
What happens if it is e to the power 2x squared?
Oh, say it again. I love this.
E to the power 2x squared.
Yeah. Or how about just e to the x squared?
Okay, yeah, that's good.
I love that. And how about just this? I'm not giving you that one on a test. Wouldn't work. It wouldn't work. Now, is there a way to look at this? Mathematicians looked at this one carefully because they knew the u sub process, the substitution rule wouldn't work there. I want to show you what would work. So here's going to be my second example. I'm going to put e to the x squared, but in front of this I'm going to put an x. Okay? Now this would work. Now let me get all this out of the way. Now we're going to let u equal something, right?
Mm-hmm.
Can I take out the word let?
Yeah.
We always let u equal to. This one will work, and Art, I think it's going to help you discover why e to the x squared alone would not work.
Okay.
So I think it's a really good question.
Is this going to also employ prodigal?
Good question. Because it has a product, it's got the product, but now it's got that e to the x squared. It's like a, it looks like
I
product,
see why.
but it's got that composite function of e to the, composed of, exponent e to the x squared. So this really is going to, it's totally going to fly with the u subs. I want to see what's going on here though. And what's that power? X to the what?
Squared.
Squared? What's this power? X to the?
1.
You'll notice in a lot of these problems, I can't say it's every problem because some of these have trig functions and logarithmic functions, but a lot of times you're going to see a power difference by 1.
1.
Let me say that again. On a lot of these, you're going to see a power difference in the exponents by what? 1.
Mm-hmm.
Do you follow what I'm saying here, Amber? Like power, like 2, x to the 2, but this is x to the what?
1.
First. You might see like x to the 5th, and I guarantee you this one over here would be x to the 4th. And you go, why is that so? Why are they giving you these in this section? Because step 1, we got to let u equal something. Where when I want you to let u equal to the one with the higher exponent.
So
I see an x and I see an x squared. So let u equal to what? X squared. Why is this so?
Ah,
Because
negative.
tell me about step 2.
D-
What do we do in step 2?
differentiate it. So
We
okay.
always differentiate with respect to x, right?
Uh-huh.
And when you take a derivative, du equals, what happens to this power?
2x dx.
Decreases by 1. Yeah, 2x. And I'll put the dx here, right? I'm going to do that every time. But this is why, and I want to point out, you're going to see this. You're going to go, oh my gosh, every problem practically. I can't say it's everyone because you get trig functions and logarithmic functions, etc. But a lot of times the power difference is a power difference by what? 1 integer. Like x to the 8th, x to the 7th. X to the 6th, x to the 5th. Because of that right there. So now, Josephine, do you remember step 3? I said divide out the what? The constant. Now when a 2 came up, so I'm going to divide what? 1/2 du. And why am I doing this? Now notice, this is sometimes a mistake. Students first learn substitution rule like maybe online or something. They think they divide the x too. No, leave everything in terms of x over here. Because we're trying to get rid of x. We're trying to change all the x's to what? u's. Does that make sense? Does that make sense? Look, see all the x's in there?
Mhm.
No, Raj, we're going to get rid of all those x's. They're all going to turn to what letters? U, right?
Mhm.
So when I'm this third step, I just divide the 1/2 to u. All right, put a box around this. All right, what's that replacing? All right, here, get it out. That becomes what letter?
E
U.
E U.
After a while, I won't have to do that every time, but the first 3 problems, I should do this. Shh, you're out. This is it. All right, and this third guy.
No, x dx.
Yes, this is going to substitute for the dx, but also the what?
X.
Does everyone see that? This will substitute, so that's what I mean. We're getting rid of all x's. This is going to substitute for the x and the dx. So here, you're out, and you're out, and what replaces it? I'll put it down here, but everyone remember our suggestion? Where should I put the half? Put it in front. Makes it look better, like makes it smooth, right? So help me write this again. Put the half in front. 1/2 here. E to the U, no more x's. Now I'm gonna go to U, Amber. We're gonna integrate this. Well, what's the integral v to the x? E to the x. What's the integral v to the u? E to the u. So I'm now able to remove this, right? I'm performing the antiderivative of e to the u, and I get e to the u. Plus a c, right?
Yeah.
Now what about that constant? The constant just what? Hangs in front. You don't have to distribute the half to the c because it's some unknown constant, right? Cool. Now, don't forget the last step. You get the test back, you go -1, minus, oh, I forgot to what? Resubstitute, right? Resubstitute, I can resubstitute. What was u? Just gotta go back and look. U is an x squared, so you get 1/2 e to the x squared plus c. Now, do you all remember Art's question? He says, what about integral v to the x squared? Can you see why it wouldn't work?
Yeah, because there is no x over there.
There's an x squared and there's no x to the first here.
Yeah.
Do you see? We couldn't do e to the x cubed, e to the x to the fourth. But if you're curious, like mathematicians, like those other rules don't even work with e to the x squared. Now you could back up, it was a definite integral, we could estimate it with Riemann sums.
Mhm.
That'd be cool.
No, what if they're the same power, like x to the e to the power x? You can do it, right? So x equals to, let's see, if it's x e to the power x, you can do that, right?
Oh, what was it again? X e to the,
X,
x e to the x you could do.
yeah, we can do
But I
that.
want to point out everyone, Calc 2.
Oh, doesn't count too?
I wish I was able to teach this. If anybody's curious about this rule, it's called the integration by parts. I call it IBP. And that's product rule right there, Cal. This is the reversal of product rule. It's called integration by parts. We used to have it in our Calc 1 courses. Some courses across the country still keep it in Calc 1. Okay? It used to be like, everybody know the AP exams? You know, Calculus AB? They used to have it in the AB. They took it out of AB. Sometimes they put it back. It's one of those. It's right on the cusp of Calc 1, Calc 2. They cut it off at one point. So, but it's fun, but that's what you'd use. And it's quick. And you go, oh, that's an integration by parts. Cool. You can kind of see it's reversal of product rule. If anybody wants to learn it, end of class, they go, show me. Take probably 5 minutes. You go, oh, cool, learn another rule. All right, great job with this. Now, this is what we're doing next. Evaluate the definite integral. So how about a 0 and a 1? That means what's here? 0 and 1. So I'm going to put a 0 and a 1 on the original one. I'll put it over here. What was the original problem? Because I scratched stuff out.
It was x e to the x squared.
All right? So if you want to write this again in your notes, because I know a lot of you are now saying, all right, it's enough definite integral. You got this, right? I'll be honest with you. I can't put these here. Or in fact, you know what? To really help students see this, make this a 2. This is the first time we're doing this. I shouldn't use 0 and 1. How about 0 to 2? Now this is important. I don't think I caught this as a student. What variable is this? dx? Everything's in terms of what? This is called the lower limit. This is called the upper limit, right? These are x values. So I want to point out, we never write it. This is really x equal to a what?
0,
We just never write, and this is x equal to a
2,
2. It really is. So those are x's. Well, I change these to what letter?
u,
So I can't put 0 and 2 here, because these aren't x's anymore. What letters are these?
u's.
U's. So, what can you do? Here's my first suggestion. Most students take this option. You go, then what do? We got to evaluate this thing. Well, this had a what? 0 and 2, x's. This is x equal to 0, x equal to 2, right? Put this change to what letters?
U.
U's. So here's my suggestion. Most students decide to do this. Don't write them here. There's numbers here, just don't write them. There's numbers, that's you, just don't write it. But when you finally get to step 5 where you what? Resubstitute and you get it back to what? X squared, then you waited. You don't put the plus c because it's a definite integral, and you put your vertical line and what numbers you put down.
0 and 2,
0 and 2. Because what letters are these? These are
X.
what?
x.
I mean, does that work?
Mm-hmm.
Yeah. So most students do that. They go, okay, I'll just wait, I'll just wait, I'll just wait. And when you finally get to resubstituting, then you get to put those original numbers down. Does that make sense?
Mm-hmm.
But I will show you what those numbers are. I gotta show you that, because some of you may like that. Okay? So Josephine, go ahead.
So when you put it back on, what, you plug those in?
That's right. Because it was an original definite integral. And this, the beauty of this, Josephine, this is the one you can check with your calculator, right? The calculator doesn't do indefinite integrals, but it does what?
Definite.
All definite integrals. So we'll be able to check this. All right, I'm gonna put, but it's gonna put in decimal form. Go
Are
ahead.
you gonna subtract them?
You got it. I'm gonna put the 2 in here for x. Then I'm gonna put the 0 in here for what letter? X. But we never put the x, do we? We just put a what? 2 and 0. But don't, everyone, if you wanna put x, you can. Okay? My Calc 3 students, when it's x's and y's and z's, I have them doing that. X equals 0, y equals 2, etc. So substitute this. What's 2 squared?
4.
E to the
4.
4?
Mm-hmm.
Then you said it's a subtraction. E, so far so good, Josephine?
Mhm.
What happened to the plus C?
Ah, remember what you said about definite integrals? Remember from last class? You could put it, but what's gonna happen every time on a definite integral? The plus c's will just what?
Cancel out.
Subtract out. So we said we don't have to put plus c if it's a
Definite.
definite integral, so I don't need that there. You could put it, but it would just subtract out when we do the subtraction. You only have to put plus c on what type? On a
Indefinite.
indefinite integral. Question, should I take off if someone forgets to put plus c on the test?
Yes.
Let me hear it. We'll take a vote.
Yes.
Take off if they forget to put plus c?
No.
I know, they're looking. I know, it's gonna happen, it happens to at least one student. You just forget to do what? You'll probably catch me on the word doing it. But this, we don't have to write it. Now, 1/2 e to the 4th, let me finish this up. 1/2 e to what power?
0, which is 1.
What's anything to the 0 power?
1.
So in my final answer, this is an exact form. I would leave it like this on the test. 1/2 e to the 4th minus
Half.
1/2. Or if you want to factor out the half, you could write it as what? And I'll put it or. If you're a factoring type of person,
E to
you
the
like to factor a lot, then you'd have to do
e to the
e to the 4th.
minus 1.
And if you, the TI Inspire usually writes it like this, factored. You don't have to do it, just you can do it like this. The calculator though is going to put it what? Decimal. This is called exact. This is the exact value of the integral. The calculator is going to give it in decimal format, you know, approximately.
Did you take points off?
Oh, but hey, hold up. Let me be careful. I would have to on my exam say find the exact value, right? Right? If I didn't say find the exact value, if I just said evaluate the depth, you might have been like, okay, I want to evaluate it. Hey, I want to show you something. What would go here? Because these were really what letters?
You just plug in the limits from previous and two.
Outstanding.
So-
Everyone, if you want to put the numbers here, if you're like, no, I want to put those numbers,
So root
they
here.
have to be what letters? They have to be U's, right?
Uh-huh.
So here, let me write it. U equals, I want to write it because I want you to point, these are U values. Then
So,
you have to go over to this thing. Remember
So-
where you did your step 1?
uh-huh.
And you got to put a 0 in here to see what your new U is for the lower limit. And you have to put your 1, no, it's a 2. You got to put your 2 in here to see your new limit. So, now what is 0 squared?
0.
But this won't be 2, will it?
4.
2 squared is a
4.
Now do y'all realize why I didn't use 0 and 1? Because 1 squared becomes a what?
1.
1, and student wouldn't make the, you wouldn't be able to see the difference between. Does that make sense?
Mm-hmm.
So you know what that means? If you put this, and you like to do that, okay, then you could be really cool. And here, you could stop here. What numbers would they be?
4 and 0.
4 and 0. If you like that, and you wouldn't have to do which step. But I'll be honest, when I grade, I always try to see how many students do this. Not many do this. Most students do what? They just wait, resubstitute, and then put the original what? 0 and 2. But I want to point this out, that it's, you could do this, and then you just, see how it's U now? And you change the what? You change the limits in terms of U.
Mm-hmm.
What would you get? You still get the same answer?
Yep.
You sure do. Now that's your option. Isn't that cool? It's your option. Did you wanna do that? When I grade, most students do what? They go, listen, I'll just use the original x's, I'll get down to the end, I'll resubstitute.
No, but that is more neat.
See, he likes this. He likes this. He'll probably do that every time. He'll change every time. He'll look to see what the new limits are. Okay? I was talking about those AP exams. They used to always create a math problem, not every year, but a lot of times, where they forced you to understand that concept. They would design it in a way that is like, you know, they make a multiple choice. Which ones would these be if you wrote it in terms of you? You know? They do that at the academy too. The mids at the academy, they get a common final. A lot of times they design it that way. So, but unless you wanted me to, no. I give students the option. Everyone gets that. I just in class, I want to make sure you're aware that you can do it which way. Tell Raj, I'm curious. Which way do you like? You know, you have an option or a preference?
Not really.
No, he goes not really. You know, he'll see. You know, when he does a problem, what he prefers to do. Cool. So that's the idea. You could have changed these because what were these letters?
You.
These were used, so you can go, oh, I can get the answer right now. And you might find that easier. You won't have to resubstitute. I was trying to hold.
I mean, if you do the substitute, it's less work.
Yeah.
I like
Good
the
point.
I like the lazy way.
All right, one. Give it a shot. I hope you notice patterns to these. Let me go over here. What was the interval of e to the 2x again?
Half of e to the power 2x plus c.
I am hoping a lot of you do spot patterns to these. All right, Amber, good luck. What do you think?
U equals to 5x.
It's like you're already experts. What do you think we'll let u equal to? And do you notice we need substitution rule? Yeah, it's not just sine of x, it's sine composed of 5x. So, we'll let u equal to what?
5.
All right, what's step 2? du equals, what's the 5